This lesson is on radians. Radian, spelled like that, pronounced radian. So, a radian is an angle measure, another way of measuring angles like degrees, but it's based on the arc length of a circle. So, if you have a circle with a radius of 1, the radius measurement is the same as the radian measurement when you find the arc length out on the side. So if r equals 1, then the angle measures 1 radian, and the arc length also measures 1. Okay? So this is going to be the way that we're going to measure our angles as we move forward in trig. So it's important that you make sure to take notes on this. So the first question that students often ask is, why? We've been working with degrees for all our lives. We're happy with degrees. What's the big deal? Well, here's actually the situation. Radians were first. Radians are based on the idea that a circle circumference is 2 pi r, and that came along many, many thousands of years ago. Radians have the advantage that they measure both the arc length and the angle. So if you remember from geometry, when we were trying to find an arc length, we had to set up an entire equation and divide by 360 and do a whole bunch of different things in order to change the angle into an arc length or an arc length back to an angle. We don't do that with radians. Before, many, many moons ago, before my time, the measurement of radians made natural sense with circles. The Babylonians actually introduced the degree because their system was based off the 360. They were 360 days in their year, and then they broke everything down in their number system into base 60, like we have base 10. So 60 was a very important number in their time. And so they came up with the idea of having 360 degrees in a circle, and it took, and all of the countries that they had an impact on accepted that, and this is where the idea of degrees comes from. So degrees came along a little bit later and were popular, but when you get into math that requires you to work more deeply with the circle, and especially with trigonometry, then it's important that you go back to radians. So I hope that gives you some small indication of why you should have to learn this now. And honestly, because it involves a lot of fractional things, I think that younger students aren't really as prepared for it as high school students are. It's based on the idea that a circumference of a circle equals 2 pi r. Okay, circumference of a circle equals 2 pi r. That's the measurement all the way around. If my radius is 1, then this pretty much goes away, and my circumference actually equals then 2 pi. So in the unit circle, unit stands for uno, 1, and that means that one complete rotation around the circle is equal to 2 pi. So if we take that to looking at our coordinate plane that we've been working on, that means if I go halfway around a circle, right, then that's half the circumference, so that equals pi radians. And if I go one full spin around the circle, 360 degrees, that's equal to 2 pi radians. Okay? So this becomes extremely important and allows us to have our conversion factors really easily, to go back and forth between degrees and radians. So the way to do it is to set up essentially a conversion factor. So if I want to end up with a radian measure, then I put pi radians over 180 degrees equals my number of degrees. So whatever measure that I want to end up with starts on the top. So pi radians over 180 will give me radians. 180 degrees over pi radians, you see what I did? I just flipped it upside down. Now degrees is on top here. That means my answer will be in degrees. So write down these two conversion factors. One will take you from radians from degrees into radians, and this one will take you from radians into degrees. Because what will happen is this degrees cancels this degrees, and this radians cancels this radians, and then my units work. Okay? So you know how to do this idea of unit conversion. Let's look at an example so that makes it clearer to you. If I have negative 60 degrees and I want radians, then I start with my conversion factor. Remember, my conversion factor is always going to be either pi radians over 360, over 180, or 180 over pi radians. Those are my two choices, either the 180s on top or 180s on the bottom. So in this case, I'm trying to change from degrees to radians. So I'm going to put radians on top, okay, because that's what I want to end up with. So pi radians over 180 times negative 60 degrees over 1. So the first thing I do is I say, oh, I have a negative 60 on the top and 180 on the bottom, so I'm going to divide those both by 60, okay? And I get a 3 on the bottom. And then my degrees cancel, and I have just radians, and my answer is the pi from over here, and the 3 from when I simplified 60 on top and 180, and of course a negative sign. Boom. So my answer is negative pi over 3 radians. We don't call those usually thirds and fourths. We usually call it pi over 3. Okay? Now in this case I have 2 pi over 3 radians, and I want to change to degrees. The one I want is degrees, so it goes on the top. 180 degrees over pi radians times 2 pi over 3. Okay? So this is a fraction, so 2 pi is my numerator and 3 is my denominator. I'm going to do the same thing. I cancel out my pi's, they go away. And then I have a 3 and 180. So I'm going to divide those both by 3, and this becomes 60. So I have a 60 here and a 2 here. 60 times 2 is 120 degrees. So think about that. Write down that example if you need it. If it doesn't make sense to you, write it down so you have a step-by-step example in your notes. What I want you to do now is pause this for just a second and convert this 80 degrees into radians and convert this 2 pi over 9 radians into degrees. Okay, because I want to end up with degrees, I want to convert this to radians, I want to end up with radians, so I would put pi on the top and 180 degrees on the bottom times 80 degrees over 1. Okay, and let's see, those 10's cancel, and I have 8 over 18, and I have 8 pi over 18. Once I've simplified things out, I'm going to multiply straight across and straight across for my fraction. But this can be simplified some more, can't it? So I'm going to divide these both by 2, and I'm going to end up with 4 pi over 9. And if it can't be simplified anymore, I'm just going to leave it like that. Now in radians, we don't always have to say radians. We can just say 4 pi over 9, or we can say 4 pi over 9 radians. For the degrees, we must say degrees, okay? So take a look here. I have radians, and I want it to become degrees, so the one I want is on top, so I'm going to put 180 on top and pi radians on the bottom. And that's going to get multiplied by 2 pi over 9 for my radians. So once again, I can cancel my pi's, and then I notice 9 goes into 18. 20 times. 20 times 2 equals 40 degrees. Okay? So hopefully those are the way that you worked it out. If not, you need to bring your questions to class and we'll go over any issues that you're having.